Good morning, class. So the last lesson that we're going to learn is parallel and perpendicular lines, which also involves slope. So hence algebra connections with geometry. We need to recall slope from algebra to apply with our knowledge of parallel perpendicular lines. And we will practice slope in a moment. First, parallel lines. For two lines to be parallel, they need to have the same slope. So we're going to say parallel lines that have the same slope. Okay, and then recall symbol for parallel was or is two lines that are vertical. That means parallel. So if two lines are parallel, then that means their slopes are the same. Perpendicular lines remember, perpendicular lines cross to form a right angle. So to be perpendicular to each other, then they're going to have negative reciprocal slopes. And the symbol for perpendicular, remember, is an upside down T. So remember, parallel lines are two lines that never cross, they never meet. Perpendicular, they do cross. However, the important thing about perpendicular is they form a right angle. Now, let's wrap our heads around negative reciprocal. Okay, negative reciprocal, that means that you change the sign and flip the fraction. So I think of it as change flip. Okay, so if you want, you could always say change flip. Okay, so let's look at some examples. So let's say that the slope of one line is 3/4, and we want the other slope that would make them perpendicular to each other, to where they will cross to make a right angle. So that means I'm going to first flip my fraction. So if I have 3/4, I now flip it and it's 4/3. And I change the sign. So I see it's a positive slope, so this needs to be a negative slope. So if I have two lines that have these slopes, then I know that they're crossing and making a right angle, which means they're perpendicular. Let's look at another example. Number 2. We have a slope of 2, and you may think, well, how can I flip a fraction if it's a whole number? Well, I can always put any whole number over 1. So I'm now going to flip my fraction, becomes 1/2. Change the sign. It's positive, it'll now become negative. Okay, so these are examples. So this is an example. If my m, how I move, the slope, is 2, then the other slope needs to be negative 1/2, so that way they meet to make a perpendicular line. Perpendicular lines making a right angle. I want you to pause this video and try out 3 and 4 and also 5. So pause and try out those 3. All right, so for number 3, you should have gotten, I flip the fraction, it's negative, so it becomes positive. So you would get 8/7. 8/7. Number 4 is 1, so I'll write it as 1/1. Well, if I flip 1/1, I still get 1. But if I change the sign, it becomes a positive to a negative. Okay, so kind of visualize. This is a positive slope, going in the positive direction. And then when I have a negative slope, but it's a negative reciprocal, it makes a right angle. That goes for all of these. Now, number 5. Number 5 says 0. 0 slope. Well, I could put 0 over 1. And if I flip it, I will get 1 over 0. And I'd change the sign. But if you put this in your calculator, -1 divided by 0, you're going to get an error. And that's because 0 slope means that I'm not rising, but I am running. Rise over run. So if I don't rise, but I run, running is a horizontal line. This next one says, okay, I am rising, but I'm actually going down, -1, but I'm not running. I'm rising, but I'm not running. So then that's why these two lines make a perpendicular lines. But we call this a 0 slope, and you can't divide by 0. You get an error. So recall that is called undefined. So if it's a 0 slope and an undefined slope, they will be perpendicular to each other. Okay, so let's look at some examples, but also refresh your memory on finding slope. So it says use slope to determine if lines AB and CD are parallel, perpendicular, or neither. So remember, parallel is the same. Perpendicular is negative reciprocal. And neither means that none of these apply. They may cross, they may intersect, but they're not going to form a right angle. Okay, so let's look at number 1. And I like this layout, how they have it, because they show you, okay, find M, the slope of line AB, find M, the slope of line CD, and then decide what type they are. So let's show our work over here. I'm going to draw a line down the middle, simply because we're finding line AB and then line CD. Okay, so let's look over here. Slope, you had heard me say rise over run. Okay, if I'm rising, that's up and down, that's my y-axis. So to find my slope M, I'm going to find the difference in the y's for rising. And running is horizontal, which is the x-axis, so I'm dividing by x2 minus x1. Okay, so if we looked at slope-intercept form, y equals mx plus b, m is your slope. M is how you move. We need to know how we're moving to decide what type of lines they are. Okay, b is your y-intercept, which is where you begin when you graph. But we're focusing on slope. Okay, so let's find our slopes. So AB, I'm going to label. See how we have to label some things. We have x2, x1, y2, y1. So I'm going to call A x1, y1, B x2, y2, and find my slope. So I'm finding the difference in the y's. So I have 6 minus 3 over my x's. 2 minus a -2. Well, minus a negative becomes positive. And let's simplify. 6 minus 3 is 3. 2 plus 2 is 4. Okay, so we found the slope of line AB to be 3/4. Now I got to find the slope of CD to then decide what type of lines they are. So let's do that once again. I'm going to label C x1, y1, D x2, y2, and find my slope. So rising is difference in y's. So 3 minus 0 over 3 minus a negative makes it a positive 1. Simplify, I get 3 over 4. I see that they are the same, and same means they're parallel. So you can either write the word parallel or you could just write the symbol. So now I have proven by looking at their slopes that they are parallel. They will never cross. Let us try another one, and then I'll have you try 3 and 4. So again, I'm going to draw a line just because how they have it laid out, it works out perfectly. I'm going to find line AB's slope. So again, you would label your x1, y1, x2, y2. So for here, AB, I have 4 minus 2 for my y's, 5 minus 0 for my x's. 4 minus 2 is 2 over 5. Okay, so the slope of line AB is 2/5. Well, let's see. Let's look at CD. I know I'm not labeling like I was, but continue labeling if that helps you. Otherwise, if you see the pattern, you can do that too, like I am. So now I'm going to find the slope of CD. 3 minus 8, y2 minus y1, 3 minus 1, x2 minus x1. Simplify. 3 minus 8 is negative 5. 3 minus 1 is 2. Negative 5 over 2. So if I look at these, all right, I see they did flip, but they also have to change signs to be perpendicular, which here they do. They flipped it. One's positive, one's negative, so it is perpendicular. All right? Okay, so pause the video and try out 3 and 4. Try out 3 and 4. All right, so for 3 and 4, you would get that the slope of line AB is negative 2/3 and line CD is 1/4. Notice that they are not flipped. They're not even alike. They're not even the same, so it's neither. They are not parallel. They are not perpendicular. Okay? Now I do want to make a note down below before, well, I'll do that in a second. For number 4, you get your slope of negative 1/3, and then you get a slope of 3. Well, I could write that as a fraction, and I can see they flipped it, and they changed the sign, so it is perpendicular. Okay, I want to make a note, though. Let's say that you had a slope, you found a slope to be 3 over 5, and the other slope of the other line is 5/3. Let's say that you found this. Let's say that you put those in the boxes in other problems. Well, they are flipped, but they're not changing signs. So this is another case where it would be neither. It looks so close to be that, yes, they are perpendicular, but they have to be opposite signs, but these are both positive slopes. So that would be an example of neither. Okay? All right. Now, let's look at other ways that we can see if they're parallel, perpendicular, or neither. Okay, determine if the equations are parallel, perpendicular, or neither. Okay, so if we look at number 18, y equals 5x plus 2, and y equals 5x minus 1. The key is to make sure it is in y equals mx plus b form, because then I can quickly see what my m is, my slope. So if I look at this, it's both in slope-intercept form. So I can see that the slope of the first one is 5, and the slope of the second equation is also 5. They're the same, so it's parallel. And you're done. Huh. If I look at 19, I see it is in y equals mx plus b format, so I can quickly see that the slope of the first equation is negative 3/2, and the slope of the second is 2/3. I see that it is flipped, and I see that they did change the signs. So therefore, they're perpendicular. Not bad, right? And if we look at number 20, notice it's not in y equals mx plus b format. So I'm going to do for both. I'm going to make sure that it is in y equals form for both so I can see the slope. So for example, for number 20, I am going to solve for y. I'm going to subtract x on both sides, and I will get 2y, pretend that's a y, that's a terrible y, equals negative x plus 2. Now I have 2y, so I need to divide everything by 2. You've got to balance it. So then I get y equals negative 1/2 x plus 1. Okay. Now if I solve for the second equation, because notice now I can see that the slope is 1/2. So the next one, I'm going to subtract 6x on both sides, and I'm left with negative 3y equals negative 6x plus 21. And then divide everything by negative 3. So this simplifies to be 1y. Negative 6 divided by negative 3 is a positive 2x. And 21 divided by negative 3 is minus 7. And I see the slope now quickly, see? So I have a slope of negative 1/2 and a slope of 2. So if I wrote this as 2 over 1, they did flip. They did change signs. So it is perpendicular. And you can always just write the symbol as well. That's fine. Okay. All right. Let's see. I'm going to have you try a few. So try out 21 through 23. If I look at this, 21, one of them, they already solved for y. So here I've just got to solve for y once. Here we had to do it twice, which I know you're thinking it's a pain, but they'll give you problems where number 21, you've just got to solve for y equals for one of them, and then you can spot the slopes. So try out 21 through 23. Okay, so for 21 through 23, this is what we should have. So 21, they subtracted x on both sides, but then they divided everything by negative 1, because that negative in front of y is like an invisible negative 1. And then we see that the slope is 1, and the slope of the second equation is also 1. The slopes are the same, so they're parallel. Number 22, they solved for y. They subtracted 3x on both sides, divided everything by the negative 1 in front, and you get y equals 3x minus 2. So my slope is 3. And then the second equation, I already see my slope to be 1/3. It's already in slope-intercept form. Now, I had talked about this earlier for a reason. This one's 3, this one's 1/3. They did do the reciprocal, they flipped it, but they didn't change signs. So this is neither. And then 23 is like number 20. You had to solve for both, get y by itself for both. You would get 2/3. And then they made a typo. That should be, and then you get negative 3/2, which is the reciprocal and also the negative. So they did the negative reciprocal, so it's perpendicular. Okay? I want you to try the remaining problems one more time, and there's a reason why I'm having you drill these. You're going to have a quiz next week over our condensed Unit 5. So please try out the rest of the problems. So pause the video and give those a try, and we'll go over it. All right, so for the remaining problems, for number 24, you would find out that they're parallel. We get negative 1/4, they're the same, so parallel. 25, the slopes are going to be the same, so it's also parallel. Number 26. 26, if you look on our, try and picture it on the coordinate plane, we have y equals negative 7. So 1, 2, 3, 4, 5, 6, 7. So here's negative 7 on the y-axis. Well, I draw a line that cuts through it. Notice that it's going through it perpendicular to the y-axis. X equals 2. So I'm going to look for 2 on the x-axis and then draw a line that way. So I have a zero slope and an undefined slope, which is perpendicular. Okay, it goes back to our practice problems when we were learning about negative reciprocals. So that's perpendicular. For 27, notice it says x equals a number and x equals a different number. So if I look at, let's pretend that this is 9, x equals 9, and then I have x equals -5. Notice they're both vertical. They're parallel to each other. They're never going to cross because they both have the same slope, undefined slope. So they're parallel. Okay, so be mindful of that. All right, now, last thing we're going to talk about is point slope form. So we learned about slope intercept, or recalled about it, slope intercept, which that is y equals mx plus b. Now we're going to recall point slope. It's as it sounds. You're going to be given a point and a slope, hence point slope form. So when you're given a point through which the line passes through, or passes, and the slope of the line m, we can write the equation like this. Y minus y sub 1 equals m parenthesis x minus x sub 1. So the first x and y will never change, but the x1, y1 is the point they give us, and then we also go back to slope. Okay, so what we're doing, what we've learned about what makes two lines parallel, what makes two lines perpendicular, and what is a negative reciprocal. We have practiced putting it in from standard form to slope intercept form so you can see the slope more quickly to then decide, are the two lines parallel, perpendicular, or neither. So now we're going to branch off one more step and look at point slope form, and then write an equation that's parallel or perpendicular to it. So let's look at some. So parallel lines. Write the equation of the line that is parallel to y equals 2x plus 4 and passes through the point -4, -1. Well, remember parallel lines, the slopes are the same, or you could just write same if you want. Okay, so like if I didn't even see any of this, and you were reading this question, you're like, okay, they gave me, they gave me a point, they're talking about parallel, so I must need to talk about slope. Oh, point slope form, point slope form. So here, I want to write another equation that's parallel to this equation. Well, first off, y equals 2x plus 4, the slope of this line is 2. And if it's going to be parallel, my equation I'm going to write is going to also have a slope of 2. So here, I'm going to label my point x1, y1. I have my point and my slope, so I use point slope form. So y minus y1. So y minus a negative, and a negative make a positive 1. My m, since they're parallel, same slope. I put 2 here. And then x minus a -4 is +4. Make sure I was reading it right. Now we're not done here. Now we want point slope form to look like slope intercept. We're learning about going back and forth. First thing, I'm going to distribute my 2. So I'll bring down y plus 1, get to that in a moment. I get 2x, and then 2 times 4, not 2 plus 4. 2 times 4 is 8. Then I subtract 1 on both sides because I want to get y by itself. And I get 2x plus 7. So I have now written my equation that is parallel to y equals 2x plus 4. Notice they both have the same slope, so it checks. They're parallel. And you're done. Let us try one more together, and I'll have you practice number 11. So number 10, write the equation that is parallel to x minus 3y equals 9 and passes through the point 3, negative 1. Okay, so to be parallel, slopes are the same. However, this is not in y equals format. So the reason why I had you practice these problems is to get used to getting y by itself. It's in standard form. I need it in slope-intercept so I can see the slope more quickly. So I'm going to solve. So I'm going to subtract x on both sides, and I get negative 3y equals negative x plus 9. I subtracted x once again on both sides. And then I divide everything to balance it by negative 3. So I get y equals positive 1/3 x, and 9 divided by negative 3 is negative 3. Okay, so now I see that my slope is 1/3. So if it's parallel, I need the same slope. I need the same slope. So this was step 1. Step 2, now I'll label and use my point slope form to my advantage. So y minus y1, it's a negative and a negative make a positive. Parallel means same slope, so I'm using 1/3. And then x minus x1 is 3. Now I get it into slope-intercept form. Solve for y. Distribute. You heard that that was my cat sign. So I get 1/3 x. 1/3 times negative 3 is minus 1. And then I subtract 1 on both sides. And I get y equals 1/3 x minus 2. So these two equations are now parallel to each other. And I can see that by when I solve for y over here, they're both slopes are 1/3. Slopes are the same, it's parallel, so it checks. All right, so I would like you to pause the video and now try out number 11. All right, number 11, I would subtract 6x on both sides and get 5y equals negative 6x minus 10. Divide by 5. Y equals negative 6/5 x minus 2. So that means if it's parallel, I need the same slope, so I'm going to be using my m value of negative 6/5. So now I come over here and I label x1, y1, and use point slope because I have a point and I have a slope. Y minus 9 equals negative 6/5 x plus 10, because it's minus a negative 10, becomes a positive. Distribute. Let's see, we get minus 12. And then we add 9 on both sides. And you should get y equals negative 6/5 x minus 3. Those two lines are parallel to each other because also they have the same slope. All right, so let's keep practicing with point slope, but now talk about perpendicular lines. So here for number 12, I see that it says y equals 3/4 x minus 1. Well, if I need it to be perpendicular, the slope I need to use is the negative reciprocal. So I flip and I change signs. So this is the slope I'm going to be using. I have my point and my slope now. So x1, y1, and use point slope once again to my advantage. So y minus a negative makes a positive 3. I need to use the negative reciprocal because now it's perpendicular. I'm just going to write a little memo there. All right, so I'm going to use, why did I put parentheses? All right, ignore that parentheses. So I have negative 4/3, parenthesis now, x minus 3. See, even they get me because I see that they're using the same integer, or sorry, same number but different sign. All right, so now we distribute. We get negative 4/3 x. If I distribute, do negative 4/3 times negative 3, I would get 4. Subtract 3 on both sides, you get y equals negative 4/3 x plus 1. So now I see my equation here, slopes 3/4. My equation that I have now got for my answer is negative 4/3. They are negative reciprocals, so I know that these two equations are perpendicular. Okay? All right. Oh my goodness, I'm so sorry you couldn't even see all my work. Shame on me. So just to say it again, I plugged in my y1, x1, distributed, and solved, and I see that these two have negative reciprocal slopes. So I know that I have the correct answer. Okay, now what I'd like you to do is pause the video, whether on the back of this paper or on a separate sheet. I want you to try number 13. Write an equation of the line that is perpendicular to x plus y equals negative 5. So solve for y to see your slope, solve for y to find your slope, and passes through the point 7.3. All right, so pause this video and now try out number 13. Give it a try on your own. Once again, solve for y, identify your slope, but then identify the slope that will be perpendicular to it that goes through this point. Okay, give it a try. Okay, so first thing, and I'm sorry if it's a little small, I solved for y, and I got y equals negative x minus 5. Well, then I see that the slope of this equation is negative 1, but to be perpendicular, the new equation I need to write, the slope is now going to be positive 1. Because if I have negative 1/1 and I flip and change the sign, I have a positive 1 for my slope. So that means I'm using m equals 1 through our point 7.3. Label, plug into your point slope form. If I distribute 1, it just becomes the same, x minus 7. Add 3 on both sides, and you get y equals x minus 4. So that means my original equation is perpendicular to the equation I have now written. I see that this was a negative 1 slope, this is a positive 1 slope. They're perpendicular. Okay? Now, last one I want you to try. Now that we've gone over this, you might have seen some mistakes or you have more clarification of how to do those such problems. So try out 14. It says, it's supposed to say, write an equation that is perpendicular to 5x plus 3y equals negative 21. That goes through the point negative 5, 1. Okay, so pause the video and try out this. This is our last problem, so please try this number 14. All right, so first thing you needed to do was we needed to write this equation to look like y equals slope-intercept. So when you solve for y, we get y equals negative 5/3 x minus 7. So in order for it to be perpendicular, we need the negative reciprocal. So I wrote that. I said, oh, okay, so to be perpendicular, my slope of the equation I write needs to be 3/5. You flip and change the sign. Okay? So once we have that down, we solve for y because they weren't nice this time. We had to solve for y ourselves and find the slope, and find a slope that's perpendicular to it. Then I used that slope. I used my slope and my point, and I plugged it into my point slope form. So I had y minus y1 equals my perpendicular slope 3/5, and then x minus the negative makes a positive 5. I solve for y. You get y equals 3/5 x plus 4. So therefore, no pun intended, our original equation before we solve for y, although they're the same, so therefore 5x plus 3y equals negative 21 is perpendicular to our equation of y equals 3/5 x plus 4. All right? Okay. So that is the lesson on parallel perpendicular lines. I know perhaps it might have been a chunk to swallow because we wove in remembering how to find slope, what the negative reciprocal is. Parallel lines are the same slope, perpendicular are the negative reciprocals, and we learned about going from standard form to slope-intercept, so we see the slope, but then we also talked about point-slope form and write equations parallel perpendicular. Okay, so your homework, which is in the attachment, okay, your homework is all the ones that are circled. So I see it's 1, 2, 3, 4. Number 5 and 6 are extra credit. I didn't talk about 7, 8, 9, so I did an example with you of how to write the slope-intercept form of a line, a linear equation, and then have you try 8 and 9. And 10 through 19 is homework as well. 20 is extra credit. Okay, so you have 3 extra credit, and I did 1 problem with you. So that means you have 16 problems for homework. I know it may seem like a lot, but promise me I'm having you drill these for a reason, to prepare you for your quiz next week over the basics of equations of circles, along with parallel and perpendicular lines. All right? All right, everybody. I will talk to you soon, and you all have a good one.